This is our final problem. So notice this one says, how can I match a graph to its equation when it is given in standard form? So the first thing that we want to do is notice over here it says which graph represents negative 4x plus 3y equals negative 9. The first step I recommend doing is convert the equation to slope-intercept form. In other words, we don't want it looking like this. This is standard form. We want to switch it to where it looks like y equals mx plus b. That way it can be easily graphed. We can identify the y-intercept very easily, and we can use the slope to check between 2 points to see if it's the correct one. So I'm going to take this real quick, and I'm going to show you the steps that you're going to use to do this. And you do have a few problems like this. So we got negative 4x plus 3y is equal to negative 9. Now the first thing that we want to do is we want to try to get y by itself, because notice that when it's in slope-intercept form, the y is all by itself on one side of the equal sign. So our goal is to isolate y. In order to do that, I first want to move this whole term, negative 4x, over to the right. Now to move a whole term over to the right, I need to do the opposite of what's happening. And right now we're subtracting 4x. That's why it says negative 4x. So I want to do the opposite, which is adding 4x. And I'm going to add 4x to the right side as well. Keep in mind that whenever we manipulate an equation, whatever we do to one side of the equation, we must do to the other side to keep it balanced. So we have negative 4x plus 4x. So that cancels. All I have left now on the left side is 3y. So we're closer to having it how we want it. Now notice over here we have a constant value, negative 9, and we have a variable, positive 4x. We cannot put those together because they're different. They're not like terms. One has an x, one doesn't. So we're just going to rewrite it with the variable first. So I'm going to put 4x. I left the positive sign off, but I'm just going to write 4x. And then this 9, we're just going to bring it down and put it at the end. And it is negative 9, so I'm going to put negative 9. Now we're almost done. The next thing I got to do is I want to get 3 away from the y. So I don't want to move the whole term over. I just want to move the 3 over. And anytime you have a number in front of a variable, it means it's being multiplied. So the opposite of multiplying is dividing. So I know that I have to divide by whatever number is in front of my variable to isolate that variable and get it by itself. Now what I want you to remember is you also have to divide that value into each term on the other side. So I always write this as 2 fractions because you're dividing it into the 4, but you're also dividing that 3 into the 9. Now 3 go into itself one time, so we always like to say these just cancel. And you end up with y is equal to my slope. It can't be simplified. Now, if you're not sure, you can always try to simplify it. I'm going to go to my calculator. I'm going to hit alpha y equals. It's always good to put it in the calculator and see can it be simplified. So I'm going to do 4 over 3. So 4 over 3. Hit enter. Notice it stayed the same. That means that that is simplified. So this is going to be 4 over 3x. And then I'm going to see how many times can 3 go into negative 9. So I'm going to go ahead and use alpha y equals, enter again, and put negative 9 as my numerator, 3 as my denominator, and enter, and notice it turns into a negative 3. So this becomes minus 3. And I'm going to box it, because we're going to use it in just a minute. Even though it didn't ask us to convert this to slope-intercept form, we are going to use it to find out which one of these graphs is correct. Now the second thing that I do when I'm doing a problem like this is step 2 is I want to eliminate graphs that do not show the correct y-intercept. So I want to eliminate that graph. So I'm looking at it and I go, okay, my y-intercept is negative 3. So I'm just going to write myself a note. B is equal to negative 3. So that means that it should be crossing on the negative side of the y-axis. In other words, if I go here to origin and I go down 1, 2, 3, it should cross here. But notice this line didn't. This line is crossing at positive 3. The same thing, I'm going to go over here and 1, 2, 3. It does not cross in the right place. So I know this one is wrong and this one is wrong. I'm going to go down here and look. Notice this crosses at negative 3. So this one right here is looking good, and this one crosses at negative 3. Now these graphs are slightly different, not a lot, but if you look, this one looks like it has an x-intercept of 4, and this one looks like it has an x-intercept of maybe 2.2 or something like that, just a little bit past 2. So which one of these is correct? So this is where we have to go ahead and we need to verify the slope. Now our slope is 4 over 3. So I'm going to write that right here. M equals 4 over 3. So all we need is 2 good points to check the slope. We don't need a lot. This one right here will be easy to check because it looks like it does have a x-intercept of 4. And so what I'm going to do is I'm going to count rise over run. And when we're looking at this, the top number is our rise. It's how far we go up or down. And the bottom number, the denominator, is our run. And it's how far we go left or right. So this, if this is correct, if I start at the y-intercept, I got to go up 4 and then to the right 3. So I would go up 1, 2, 3, and then 4. So I'm going to count that again, and I'm going to draw little curly cues. 1, 2, 3, 4. So if I go up 4, and then I go to the right 3, so I'm going to go over, I'm going to use my black pen for that. I'll go over 1, 2, 3. There should be a line. The line should cross through that point. So notice this is off. So this is not going to be correct. So this one right here is wrong. Now let's check this one and see, does it look like it would go through that point? So once again, I'm going to do a rise of 4. So from the y-intercept, I'm going to go up 1, 2, 3, 4. And then from there, I'm going to go to the right 3 units. So I'm going to go ahead and I'm just going to extend these lines a little bit. So I would go over 1, 2, 3. And notice it hits right there. So I have a run of 3. I have a rise of 4. So I know that that is the correct answer. Now the other way you could have done it is since we got the equation, we could have graphed it. So I want to show you what that looks like. To graph an equation, you use the y equal button. Because notice that's what it says down here. It says, or enter the converted equation into your calculator to graph it using the y equals key to match the x-intercept and y-intercept. So where it crosses the x-axis and where it crosses the y. So what I would do is I would just hit y equals and I would type in this equation. So alpha y equals enter to get my fraction bar. I have 4 over 3. And then I have x and then minus 3. And I'm going to go ahead and hit graph. So you can see what this picture looks like. And just by looking at the picture, I realized real quickly that it has to be this graph. Because the x-intercept looked like it was right past 2. If you look at the up here, right, this x-intercept is right past 2. This one's right past 2. And if you look, it crosses through negative 3 on the y-axis, crosses through negative 3. So it doesn't match this over here. Another thing you could do is if you could even look at the table if you wanted to. You could actually hit second and then table. And you can look and see at what points it crosses. So it crosses at 0, negative 3. We knew that because that's the y-intercept. And it crosses at 3, 1. And that would make sense, right? Over 1, 2, 3, and up 1. So notice this one right here. If I go over 1, 2, 3, and up 1, it's right here. That line does not cross through that point. So there's more than one way that you can view it. So now that you're done with this, and we've completed the notes, you're ready for all the activities that you have today. And at the end of class, I'm going to have you write a summary. So don't write a summary right now, but at the end of class, you're going to write a summary. And we're going to use these sentence stems in the summary. You're going to first say, today I learned. And then you're going to tell me what you learned about. And your goal is to use these words in the summary. Period. So you're going to finish that sentence. Today I learned. You might say, I learned how to find slope and how to match a graph. Whatever it is that you felt that you learned, you're going to write it in that first sentence. And then you're going to pick one problem from these notes that you're going to explain how to solve it. It doesn't matter which one, but you're going to pick one. And you're going to start out by saying, first, you need to. And you're going to tell me what you did first to solve that problem. So you'll fill in the blank, right? Everybody's just going to look different because everybody's going to pick a different problem probably. So first you need to, and if I was doing, this problem right here, I might say first you need to convert from standard form to slope-intercept form. And then you're going to say, next, you should. So we're going to create another sentence. And let's say I was doing, I don't know, let's say we're doing the very first problem. Let's say we're doing the word problem. So after we did our first step, next you might say something like label the slope and y-intercept. And then you're going to say the final step that you did to solve the problem that you chose off of the notes or that you chose from the day, because you can pick any problem you want to explain it. And on that one, we're going to say, last of all, you must, and you're going to finish that sentence and tell me what was the last and final step that you did in order to solve your problem.